They're hunting for the mic back there. How we can go ahead and get started. We're talking tonight about the age of the earth, but in a few moments we'll be extending our Savior's invitation. If you've not obeyed the gospel, we hope you'll think seriously about that. And then we hope some of you have some questions. Thank you, sir. The great age, billions of years, is absolutely essential for the evolutionists, and of course that's why they are one of the reasons why they believe in it. They have no alternative. If the earth is young, then the creation evolution controversy is over. We can all go home. There's no time for evolution. It's impossible. And so a great many have been convinced, not basically by the evidence, they just hear over and over again that the earth's billions of years old. It is absolutely essential to their faith in the naturalistic origin of what we see in this world. But not all scientists believe the earth is billions of years old. That's the impression they would leave. There are literally thousands, like Russell Humphreys, for example, has his doctorate from LSU. He's a geophysicist. He worked at Sandia National Laboratory for over 20 years. He has about 100 patents. He is certainly a credible scientist and is completely convinced that most, his statement was, 90% of all the age indications indicate a young Earth. But you hear about the 10% that can be considered indications of old, though there are alternative views there. To get an idea of the necessity and the philosophical requirement of the great age naturalist evolutionist, let's notice the statement by George Wall, who's a Nobel laureate from Harvard. In his book, Physics and Chemistry of Life, he says, one only has to contemplate the magnitude of this task, and he's talking about the naturalistic origin of life, the, quote, simple cell, which is a foolish description. How do you get that kind of complexity naturally? He says, you just and you can see that spontaneous generation of a living organism is impossible. Yet, here we are, I believe, as the result of spontaneous generation. Now, you wonder how a person can think that way. He sees problems he can't begin to answer, but he has to believe that in order to be a naturalist. Or any of the steps which it involves, given enough time, it will almost certainly happen at least once. Time is, in fact, the hero of the plot. Now, what we learned about time last evening makes that a very difficult statement. I think time is the enemy, not the friend of the one who's trying to increase organization through time. Given so much time, he says the impossible becomes possible, the possible probable, the probable virtually certain. One has only to wait, and time itself performs the miracles. So that is the Holy Spirit of the evolutionist. I think it's impotent. It does not produce order. It does the opposite. As we saw last evening, time degenerates, and that's what we experience in our everyday life. But why would he? Well, he has no other alternative, and he sees it's impossible, and so that's where he goes. Why does he do that? Well, he tells us. We don't like to judge motives, especially of individuals, but he says, a supernatural creative act of God. I will not accept that philosophically, because I do not want to believe in God. Therefore, I choose to believe in that which I know is scientifically impossible, spontaneous generation arising through evolution. Now, this he said in Scientific American, out loud in front of everybody. Usually they say it behind closed doors. But I think he's telling the truth. He is driven philosophically by his determination not to accept God, to believe in naturalistic origins. And time is the essential element that allows him to do that, he thinks, even though that doesn't really solve the problem. I think one of the best ways to begin dealing with an issue scientifically is to ask why questions. You think this is the case? Why is that so? Can you defend that proposition? When we ask that about the age of the earth, why do you believe? Most of them are not going to say, well, I don't want to believe in God, so I have to. And they have to come up with a better answer. Most of the time, people will respond saying, well, radioactivity, radiometric dating has proved that the earth is billions of years old. And of course, everybody understands exactly how the radiometric dating systems work, or do they? These young folk are not quite sure what the radioactive dating is about, but it's not, we don't find that many people that do. And we're not going to give a course in radioactivity this evening, but I think we can get a general picture of how this works. Radioactive material is material that is not stable. The atom itself emits alpha and beta particles, decaying then and becoming a different element. And it supposedly tells time something like an hourglass. Here's uranium-238 up at the top. That's the way it begins. It decays down through a series of elements, winding up losing 32 of those 238 particles to become lead-206, which is stable. Now, that process is happening at a constant rate today. Was it that way in the past? Well, that's a good question. We don't know, of course, but at the rate today, it's supposed to tell us time like an hourglass. Now, and you can get very technical with the equation that you see at the bottom. What could go wrong with this kind of a time-telling mechanism if we use the analogy of the hourglass? We see it takes an hour to have the sand at the top go down to the sand at the bottom. So what could be a problem with that time-telling mechanism? Well, suppose just before you were asked to look at this and say, all right, that's an hourglass, how much time has transpired? Someone had lifted the lid and poured in a lot of extra sand. And it would look like maybe, 15 minutes or less? But actually, it was almost all down at the bottom until somebody poured in a lot of extra at the top. That would mess up the calculation, wouldn't it? Or suppose somebody lowered the base, opened it, and let most of what had already gone down escape. That would, or maybe it was basically like this, laying on its side, and somebody set it up and said, now then, how much time? And it'd been 15 seconds instead of 15 minutes. These are the kinds of problems that we can see with the hourglass analogy, and that does correlate with the radioactive dating. Henry Fall, who's one of the leading experts in this area, author of the book Ages of Rocks, Planets, and Stars, says there are two important assumptions implicit in this equation, the one at the bottom that allows you to tell time like an hourglass. All right, what are the assumptions? Now, see, you don't date the rock, actually. That's a shortened version. You measure sample activities and then through a set of assumptions reach a conclusion about the age. There are two important assumptions. First, that we're dealing with a closed system. In other words, nothing leaked in and nothing leaked out. If that were the case, then it wouldn't tell time. And second, that no atoms of the daughter, that's what's produced at the bottom, were present in the system when it formed, that it started at zero. It wasn't laying on its side halfway there. These assumptions furnish the most serious limitations on the accumulation clock. He continues, rigorously closed systems probably do not exist in nature. Well, no, you have to have the closed system for it to work, and there are not any in nature. And we see this with the fossilization process. We see the calcium carbonate seashell becomes pyrite. It is metallic in the process of being fossilized. Well, the water percolates down through, leaches out some material, adds other material, and it changes through. This is not a closed system, and you have to have a closed system for this to tell time. Surprisingly, he says, many minerals and rocks satisfy the requirement well enough to be useful for nuclear age determination. The problem is one of judicious geologic selection. So in other words, you just add and subtract. You pick the one that works. It works in terms of coming out, quote, right. And you begin with the assumption and you keep trying until you get it. Now that's the way I would say it. Probably not the way he would, but judicious geologic selection. You pick the rock that works. Let me give you an example of that from the evolutionists themselves. Roger Lewin was editor of Research News and Science magazine when this was written, Bones of Contention, which is a book about fossil man, and we'll be talking about that, Lord willing, Friday evening. He's one of the experts in that field. And he's talking about his friend Richard Leakey's discovery, 1470 skull. And the date is the ball game. I mean, if it is somebody that died yesterday, it's not interesting. But if it was millions of years ago, then you can make it fit and tell a story. The calculated age was quickly refined to be 2.61 plus or minus 0.26 million years, which to anthropologists unfamiliar with the process of radiometric dating has a ring of comforting precision. Now, if you're unfamiliar with the procedures, you're not by yourself. Many times anthropologists aren't either. They just take it to the lab and say, date this. However, the lab won't until you tell the lab what date it's supposed to be. If you don't believe that, you just look at the forms you submit. You can try that, and they got to know the answer. Now, when I was in school, I didn't get the answers before I took the test, but they have to have that. But 2.61 plus or minus 0.2, it sounds very precise, which is very misleading. And this is the point that Lewin is making here. There were 41 separate age determinations. Now, 1470 skull got around. This was a popular lady doing a lot of dates, 41 different dates, which varied between 223 million and less than 1.91 million. Now, that's a huge range. 41 dates, and they're all over the place, and never again obtained the 2.61. But that's what they published because they judiciously selected it and it fit the story. The rest you just toss, don't hope they don't find out, but here's his buddy, friend, who is pulling the curtain back and you can see what's going on. That's the kind of thing that we need to understand. They're not dating a rock like looking at the clock. They're, through a set of assumptions, reaching conclusions, and those conclusions are certainly not hard and fast. Another example, one of the ways to test this is what you might call the proof of the pudding type. Let's just see how well it works. Sometimes you have the answer, and you know how old rock is. This is the caldera at Mount St. Helens, erupted in 1980. And then there were several other eruptions after that. In the center here, we have some that had fairly recently erupted. 1997, they took 5 samples from the caldera. Now, we knew when it originated. That originated in 86, 6 years after the original eruption. Okay, 86. Let's date it and see how it comes out. With potassium argon dating, it came out somewhere from 500,000 up to almost 3 million years, and it was actually 11 years old. Now, how that happened, the people that submitted it are supposed to tell where it came from and what the age is that they expect, and they didn't do that. I would not have done it the way they did it, but they fudged it in their submission form so that they could show this. I don't think that's a really good reason to believe the Earth is billions of years old, and certainly not the kind of thing that would shake one's faith. 3 million, 11 years, that's a little different, isn't it? We hear a lot about the radiocarbon dating, which is not as significant as we get the impression of. We're talking about millions of years for evolution, whereas radiocarbon only deals with tens of thousands of years. It would totally decay in 50 to 60,000, usually just a few tens of thousands of years. But if we have something 30,000 years old, I think that is a challenge to what we see in Scripture. And again, just to get to kind of the proof of the pudding type, let's see if it works. Look at the results of the RATE project. That's an acronym, but some creationists were collecting samples, very highly qualified scientists, including Russell Humphreys that I mentioned a moment ago, and dating dinosaur fossils as well as coal and diamonds. You have to have something with carbon in it for carbon-14. And immediately the evolutionists would say, no, wait a minute, this doesn't make sense because it's all gone in tens of thousands of years. The dinosaurs did at least 65 million, and the coal is 50, 100 million, and maybe 300 million. The diamond's older than that, billions. And so you're dating with carbon-14, which is all gone in just tens of thousands. There should be none there at all. But the problem was all of them had significant amounts of carbon-14, indicating just tens of thousands with their own system. What we're seeing is that the answer is in thousands, not billions, which is the creationist trend. That fits our view and absolutely demolishes theirs if they're going to depend on it. And while we hear a lot about radiocarbon, these findings, especially from the RATE project, have really shaken a lot of them up. Here, Center is writing 2020 in the American Biology Teacher. It says, the recent discovery of radiocarbon in dinosaur bones, see, would all be gone in just tens of thousands, but it's supposed to be 65 million at least. The recent discovery of radiocarbon in dinosaur bones at first seems incompatible. Well, it obviously is incompatible with millions of years. And so he says it consistently yields a falsely young radiocarbon date. A few thousand, a few tens of thousands of years. It has to be false. They just know the answer before they take the test. And so he says bone material, fossil or otherwise, is material that cannot yield an accurate radiocarbon date. And so they just give up. The ship is sinking, the rats abandon the ship, and radiocarbon doesn't work anymore. Now, you haven't seen that in the headlines, but that's being acknowledged. I think the RATE project was a very important project. The absolute dating assumptions, then, are first that it's a closed system, And really they don't exist in nature. You just have to keep picking until you get the one that works. And then the beginning conditions, you have to assume that in order to make it work. We do know that, quote, known ages contradict when you know when the rock was formed. And you know that old things are not old with the rate project. And so those are very significant problems. These are reasons why I don't put a lot of confidence in the radiometric dating systems and why it's not a challenge to our faith. In fact, W.D. Stanfield, who is a vicious anti-creationist, professor of biological science, Polytechnic State University, California, says in his book, Science of Evolution, he's a devout evolutionist, it's obvious that radiometric techniques may not be the absolute dating methods they're claimed to be. And then says there is no absolutely reliable long-term radiological clock. And I think we caught him in the truth. I agree with that completely. So when we look at some of these problems that you don't really hear about in the headlines, you don't have that much confidence anymore. Now why? Why do you conclude the Earth is old? Well, it looks old, we're told. Well, I think that's programmed looking. I think it is better explained from a young Earth, and let me tell you why. Geologic phenomena, when they say it looks old, they're talking about the layers, the fossils, the oil, the coal. I think it doesn't look old. I think it looks flooded, and I think that's a better explanation. It's interesting that that's exactly the explanation that they see when they look at Mars. Here from the New York Times, signs of great floods on Mars. Deluge that swept over much of the red planet, a catastrophe that perhaps only Noah could appreciate. New York Times is usually not in favor of creation. Here in Nature, likewise, probably the most prestigious science journal in the world, 2020, Mars Noachian stratigraphic record. Interesting comment. You look at these stratigraphic layers, these horizontal layers that are laid down by water, and yep, that looks like a flood. And they acknowledge that when there's no water on Mars. But we see layers like that on Earth where we have 70% of the surface covered by water, an average of 3 miles deep, and no floods here. The layers, horizontal layers, cover the continents to an average of about 1.5 miles, and they just refuse to see a flood. They avoid by seeing millions of years, and that's the assumption. What their assumption is, revealed here in the book Great Dinosaur Extinction by Officer and Drake, that less than half an inch is involved in 1 million years. If you got a half an inch, then there's 1 million years of time. And so if you're looking at Grand Canyon, you're looking at a lot of time, or 1,000 years here for less than half an inch. Now, when you study the rocks, that assumption, and of course they begin with the conclusion of how old it is, and they divide that into the rocks and come up with these conclusions. Looking at the rocks, you got a real problem here. Principles of Stratigraphy was a text I was taught from at 2 different state universities. To some thoughtful stratigraphers, this presented a dilemma, that is the idea of great ages. There's very good evidence the individual beds accumulated rapidly. Now, that's not what you normally hear, but what is he talking about? When you look at the rocks, there's very good evidence that it accumulated rapidly. Well, if there is, then you see the dilemma he's talking about. We're looking here at shrimp. And you ladies know that you can take the shrimp and put it in the refrigerator and it just lasts for years and years and years. Or does it? Or if one dies out on the beach, how long is it going to last? It stays there a million years while a rock goes around it, or 1,000 years, or how long is it going to look like this? So how long did it take that rock to form before the shrimp could decay? If we just think, yeah, very good evidence that happened rapidly. We look at this fish who's in the process of eating his supper, and he is fossilized. How long did it take that rock to form? Formed while he was eating supper. How long does it take a fish to eat supper? They don't play around at it usually. They just go for it. This is not unusual. We have a number of examples of these in our museum there in Little Rock. That's very good evidence that these rocks occurred rapidly. Let me just show you some absolutely knocked down, just proof that it didn't happen slowly. Here's a school of fish. Not just the fish fossilized, but the school in formation. How long do they stay in formation? They all die in formation and fall down to the bottom in formation and stay. Here's a close-up. That's the part that Officer and Drake had mentioned. They said a rate of 1 centimeter per 1,000 years, a little bit less than half an inch. That's what we see represented here, and there's several fish. That would take 1,000 years at their rate. Now, Roy Polnick, who's a paleontologist, University of Illinois, just says this is a challenge. I can't picture a three-dimensional school of fish sinking to the bottom and maintaining all their relative position. That makes no sense to me. It makes good sense that it makes no sense. I think we understand what he's saying. This is a instant snapshot. This is not something that happened 1,000 years per half an inch. And here in Nature Reports 2019, we have a picture of some trilobites, all lined up, as the title says above it, fossilized while playing follow the leader. All lined up, and you can see this on the ocean bottom. Lobsters and others do that. Trilobites go marching one by one. The trilobites' careful cue. Frozen in place. Now, can you explain that in terms of 1,000 years per half an inch? That just ain't gonna work. We look at a fossil fern here that's a little over 12 feet tall. We've got a coal seam down at the bottom, another coal seam up at the top, and hundreds of layers in between. Now, if it's taking half an inch, 1,000 years for half an inch, what's going to happen to the top of that fern? Here I am sitting beside it here in the coal seam, looking at it going up overhead, just over, and it goes way on up higher than the 12 feet, but that's what's represented here. We back up a little bit and we see the smaller ones side by side. There are at least 4 of the fossilized ferns here, formed at the rate of 1,000 years per half an inch. How long does it take a fern to wilt? They weren't that big, aren't that big today, but they were back in the fossil record. We saw a little bit about that last night. I think there's a better explanation for this gradual process. I think it was one catastrophic event they were buried at once as they were, and that explains what we see. I don't think it's possible to explain that slowly. I'm sitting on the coal seam, and that kind of introduces the subject. Here's a fern leaf in the coal. Compare that with the one that's been over at the top, which is a fossil. The one that's been over at the bottom, of course, is in life. You turn it loose, it springs back, but this was fossilized before it sprang back. In fact, here in Science Daily, it says the preservation happened so quickly that some cells have even been preserved during the different stages of cell division. Now, you ladies know a little bit about ferns, and how long does it take for a fern to wilt? Not very long. But this, and many of them, were fossilized before they had time to wilt, even while they were in the process of the cell division. All fits into the same category, and we are programmed to think it takes a long, long time. Here's an article from the U.S. Department of Energy talking about making oil out of algae. Algae to crude, it takes minutes in the lab, reported recently in the Journal of Algal Research. Crude oil, less than an hour. Now, it takes a little more energy turning it into oil than you get out of it. And we're working to see if we can break even or make a profit there, but it doesn't take a long time. Very good evidence when we look in the rocks that it happened rapidly. This is an ichthyosaur, which is a large reptile, lived in the ocean. This one is actually not the largest by any means. This one's 28 feet. Now, a 28-foot critter would reach most of the way across the auditorium here. We did find one reported just a couple of months ago, 85 feet long. This one's just 28. But we look at how well it's preserved. Up on the head, we see the adipose, the fatty tissue. That's beautifully preserved. How long will that last? And looking at the interior, this is a mama ichthyosaur. They did give live birth, and here we see the embryo inside. And some of them were obviously disturbed in the storm that buried them, the flood, and produced live birth. And we catch that in the limestone. And that has been seen numerous times, which is maybe what happens when they get buried in a flood. They get all excited and premature birth. But there's baby ichthyosaur protruding, coming out. This is what we're talking about when we say very good evidence that this happened rapidly, frozen in the limestone. Another one was reported just recently in PLOS 1, capture the moment of live birth with a baby emerging from the pelvis of its mother. That's what used to be known as a Kodak moment. That's, I guess, a little dated today. But that's very good evidence that it didn't take a long time, that happened rapidly. That's what we see when we look at the rocks. Some of you will recognize this creature as a jellyfish. I was lecturing at junior high one time, or actually I think it was elementary, and asked what are jellyfish made of, and a little girl waved her hand. I know. She said it's made out of snot. Whatever it's made of, it was substantial enough to be preserved in the fossil record. And here are those very ephemeral jellyfish, preserved along with the ripple marks, which move from moment to moment, in the rocks. Very good evidence. These are 1.6, about the size of a dinner plate, jellyfish, and then different styles. We see up in the upper left-hand corner of the diagram and the fossil, and that's from the Cambrian. That's supposedly the lowest layer. Very, very good evidence that the strata was rapid. There's good evidence, and this is not just imagined. We don't have to pick the rocks. This is what we see when we look in the rocks, and there's no way to explain that slowly. Very good evidence that individual beds accumulated rapidly. We see preserved soft tissue, and this is not a new phenomenon. The jellyfish are like that, but here's a quote from Fitzorg. Burgess Shale preserves soft tissue in exquisite detail. This is up in Canada. The question of how this came to happen has troubled scientists since the discovery in 1909. They hadn't figured this out since 1909. Over 100 years to work on that, and how do you answer that? It's troubled scientists. But if you think that's trouble, that is finding the soft tissue preserved in the hard rock, what about the preserved soft tissue that's still soft? That's in the rock, supposed to be millions of years old, like blood cells. These are in a T-Rex bone, supposed to be over 65 million years old, and they've got blood cells. You can see the tissue that's squishy. You pull it out and it snaps back when you dissolve the calcium carbonate away, the outer part of the bone. Mary Schweitzer, who is an evolutionist, reported this, and here it's reported in Discover. She published in several of the journals. She was in the process of getting her doctorate and almost didn't get it because she published this. But she did and has proceeded with even more dramatic finds. But here Discover reports her saying, I had one reviewer tell me he didn't care what the data said. He knew that what I was finding wasn't possible. I mean, there's the evidence. You see the squishy, soft tissue in the T-Rex bone. Don't care what the evidence is. It's not possible. I wrote back and said, well, what data would convince you? And he said, none. I've talked to some people like that and tried to teach what the Bible says, and I've seen them have, maybe not quite that obvious, but we've seen that attitude, haven't we? Scientists are people like everybody, and they've got ambitions and they've got careers to think about. They like to feed their children, and they're going to lose their job if they don't maintain the position, lose their foundation grants, and lots of motivation. Doesn't matter what the facts are sometimes. And the facts are accumulating, and Mary Schweitzer is, and I've talked to her on several occasions, she doesn't accept the implication. Here are the facts. She says, you make of it what you will, but it has recently come to light that there is actually original DNA preserved in the fossil bones. Here's Fitzorg, 2020. Dinosaur skeletons found with fossilized chromosomes, preserved DNA. What next? Now, I've had people say, you can't do that because DNA is not going to last very long. DNA, we have to repair our DNA every day. And when you die, it deteriorates. I've had that challenge, so I just took a picture of one of the technical journals. Here's evidence of proteins, chromosomes, chemical markers of DNA in exceptionally preserved dinosaur cartilage. Now, what did they say about that? The possibility, and this is in the article, Fitzorg, that DNA can survive for tens of millions of years is not currently recognized by the scientific community. Well, no, not possible. It is generally accepted that DNA persists less than a million years. In fact, the technical journals went on to say there's no way it's going to last that long. One of them theorized that if you freeze it at absolute zero, and keep it at absolute zero for 1,000,000 years, maybe, but no longer. Well, the Hell Creek Formation up in Montana is not anything like that, I can tell you for sure. Generally accepted, obvious, but it's got to be 65 million years old in order to fit the facts. Here's Michael Benton, professor of vertebrate paleontology at Bristol, discussing the problem. We now also know that DNA molecules break down very easily and will typically survive only a few years. That, I mean, it is not hidden. We know we get bones from the museum and try to get DNA, and sometimes we can, but it's the older ones are very unlikely. By using massive computing resources, DNA from fossils maybe 50,000 years old can be reconstructed from millions of short fragments. The older, you keep trying, and sometimes you can get a fossil, and of course I'm questioning how they conclude it's 700,000 years old, but the oldest that we have with DNA in it is 700,000, a long ways from the 66 million years of the last dinosaur. You see their problem? He's not offering a solution. That's an impossible challenge. So what we're seeing when we look in the bones is that the fossils are not old, that the rocks that preserve these fossils, like with the ferns sticking up through them, the jellyfish, they happen rapidly, and the fossils in them are not old. Therefore, we look at pictures like this and just think, if the fossils in the layers are not old, and they can't be, we've got DNA in them, then the layers are not old. Doesn't that follow? And if layers are not old, then my question is, where's the time that they insist is here when we look at this? Well, they have a response to that. Today's answer is, when the layers had to form rapidly and the fossils themselves are not old, well, the time, we're told today, is in between the layers, where there's no evidence. But that's where they put it. Derek Ager, who at the time this was written was president of the British Geological Association, says we cannot escape the conclusion that sedimentation was at times very rapid. Some won't, but you can't escape that. At times, indeed, other times there were long breaks. How do you know that? Well, it looks uniform and continuous, but there had to be breaks. And it's in those breaks that he shoehorns the time. It looks continuous, and when you know something about sedimentation, if it's exposed any time, you got erosion in between. These don't look like there's erosion in between the layers. It's one right after the other. The geological record is constantly lying to us, he says. It pretends to tell us the whole truth when it's only telling us a very small part. May seem paradoxical to me, the gaps probably cover most of Earth history. The evidence is not there, but it's in his head, and it's in the gaps that he can't see anything in. It was during the breaks that most events occurred. It's the gaps. Now, I was taught that it was the actual facts, the data, the fossils that mattered. No, it's where there's not anything. That's where we put the time. And we look for at an example here down toward the base of Grand Canyon. Here's the Coconino Sandstone, the Hermit Shale, one on top of the other. In between is 110 million years. You buy that? Now, if you got it exposed for any time, you don't have straight knife edge interface like you see here. You look at Grand Canyon and you see straight, smooth lines. Time produces erosion, such as we see here. But that's not what you see here. It's one right after the other. And we looked at the contact lines. Sometimes you separate them and you see in between little bird tracks. That would erode away if it's exposed at the surface in less than a year. You see ripple marks and raindrop impressions and animal tracks, sometimes some pretty good sized tracks like these down at Glen Rose we'll look at later this week. Here, the layer that preserved them had to form rapidly, or the next rain would wash them out. And then, if they are preserved rapidly and then exposed at the surface, just a few years is going to erode the tail at the surface, so the next layer had to be rapid in order to protect it. So the host layer is rapid. The next one on top of it has to be rapid, one after another, which is what we see here. All of the layers have ripple marks, and those ripple marks are erased if they're exposed for any period of time and would not be preserved if the rock weren't formed quickly. That says all of this was rapid, if you just follow the evidence. But to show you just real dramatic illustration of this, and you have to think a little bit, this is the Red Wall Mississippian. That's the most dramatic layer that you see in the canyon, supposed to be 340 million years old. Underneath is the Muav Cambrian, supposed to be 515. 175 million years missing between the two. That's all right, there was erosion that left this knife edge. But that's not exactly what it's left. Here's skipping from the lower one to the upper one, 175 million years. But look closely at the interface, and I believe we can see that. We see the red wall, and then we go back and we have more of the Muav, and then we have more red wall, and we have more Muav. It goes back and forth 8 times. How do you skip 175 million years and then go back and get some more, and then skip 100? That's nuts. When they are interbedded, they are contemporary. That's just common sense, and in fact, we were taught that in stratigraphy. That proves that the layers are contemporaneous. The textbook says they're 175 million years apart, and it is not difficult, it's just not possible that they are apart. It looks continuous, and it is, and the interbedded nature demonstrates that. Cannot be millions of years apart. So, how did so many layers form rapidly? Well, I think they did so catastrophically, and we can see catastrophic deposition of sediment just like this. For example, at Mount St. Helens, occurred in 1980, blew the top, blasted a tremendous amount of material, and sent a pyroclastic cloud across the countryside at about 150 miles an hour, putting the trees down in Spirit Lake and laying down about 600 feet of sediment, one layer after another at 150 miles an hour one afternoon. Then Spirit Lake, the dam broke, eroded down through the newly laid sediment, and here's a little trickle down at the bottom that eroded this huge canyon, you think? No, it was a lot of water that eroded it. The little trickle is what's left. And that's what we see at Grand Canyon. But these are the layers that were formed rapidly, catastrophically, one after the other, in 1980 at 150 miles an hour. How long does it take layers to form? Well, you don't stand around for a million years and watch, but you could see this happen in one afternoon and see the fine layers, and sometimes look just like the rocks that you see at the road cuts today. And we know they formed rapidly. And we look at the overall picture, and it looks a lot like Grand Canyon. This is Mount St. Helens, and we look at it, and it looks very similar. I'm sorry, that is Grand Canyon. This is Mount St. Helens, and you can hardly tell the difference. Reminds me of the cartoon that a friend of mine drew. This million-year-old canyon was formed by Mount St. Helens in 1980. We go to the caves, and hundreds of thousands of years to form the speleotherms. Some of them reach all the way to the ceiling. That's just not the case. George Rogers Clark Memorial, Vincennes, Indiana, right on the banks of the Wabash River, has a basement full of speleotherms that were formed since that was built. Here's those drapery-type formations and the 11-foot columns. There are 6 of those reported there in the press. They understated this. It opened in 1933, and 2009 was 76 years later. So here's a 11-foot column that they have pictured there that formed in 76 years. That's not the story they tell you. Another demonstration of that, we go to Carlsbad Caverns, and you see lots of bats flying around. This was a very slow bat. They got caught by a stalactite. He died, landed on it, and it covered him up before he could decay. How long did it take that stalactite to form before the bat could decay? And all kinds of things that are supposed to be petrified don't take that long. We have numbers of examples. We've got a teddy bear that's petrified in our museum. This I found out in West Texas near Iran. The boot is not petrified, but the bones on the inside are, including the flesh of this unfortunate cowboy. You look carefully at the bone material, you can see the wounds, the pus. We took that to one of the hospitals there to have them do a CAT scan so we could see the bones down in the boot. And they had to put some name on it. It came back unfortunate cowboy. We prefer to call him the limestone cowboy. But the boot was made by the J. Letty Boot Company in the early 50s, and the bones are petrified. Doesn't take that long, and we can prove it. The rapid and young indication of the rocks is obvious. When we look at the shrimp and the fish-eating shrimp and the jellyfish, the ferns going up through many layers, and the DNA in the dinosaur bones. The sequential layers are seen to be rapidly one after another, especially when we compare it with Mount St. Helens. And rapid petrification is seen with the boots and the bat, and the coal and the oil we can reproduce in the labs. Where's the evidence of great age? It's rapid, it's young, it's continuous when you just look at the facts. So now, why do you think the earth is old? I don't think it looks old at all. I think it looks flooded. And I think that's a much better explanation. Now, in the 3 minutes I've got left, let me run quickly through young earth evidence. That's a week's seminar in itself. But these are indications of a young earth from W.D. Stanfield, who is an anti-creationist, and he said, well, there are some indications of a young earth. We won't look at all of these. I'll just go right to the bottom and look at the last one, population dynamics, and illustrate what he's talking about. If you have 2 people, you got to, in order to test population dynamics, you got to know the growth rate. Well, the U.S. growth rate now is 0.81, which is a lot slower than it has been. That's just, in fact, it's not even keeping up, not growing at all at that point. But let's just move it back to 0.46, and we're kind of playing with the numbers. This is an extremely slow growth rate. And just go for 200,000 years. Now, that's nothing compared to what they say is represented in the fossil record. 200,000 years, growth rate, 2 people, 4.312 times 10 to the 398th. Now, if you're familiar with scientific nomenclature, you know that's an absurd number. For example, there's electrons in the universe is 10 to the 65th, and this number is 10 to the 398th. It's an absurd number. It doesn't work. On the other hand, we got 8 people at the same slow growth rate for the period of time since the flood, with 8 people, and we come up with 7 times 10 to the 9th, 7 billion, which is right on. Which model works better? One's absurd, one fits like a glove. And that's what we see over and over and over again. So that when we compare the two, on the one hand, we've got really good evidence of the young age. On the other hand, the geologic phenomenon and the radiometric dating age indication of old age, that doesn't work very well. That's pretty light evidence. We could just summarize it in saying we've got more and better, and they've got fewer and not so good. So that if you're a scientist, your conclusion is that the Earth is young. I believe the most scientific explanation is that we're looking at thousands of years, not billions. That does not work as well. The book that describes this says it wasn't that long ago, and also indicates it won't be that long before it'll end. And if it didn't begin but just a few years ago, then the end becomes much more realistic and imminent, doesn't it? If it's billions of years old, you don't worry about next Thursday. But if the book that describes the beginning not too long ago says it's coming soon and you need to be ready, it puts a whole different perspective on the world, doesn't it? And your responsibility to God. If you haven't obeyed, you don't know that you have time. That time is running out. We'd encourage you to respond now while we stand together and sing.